This is going to get started. I think we might be live. Let me just double check on the stream. All right. All right, we're live. All right. Hey there, everyone. Thanks so much for joining us. My name is Ben Rojan. I think a lot of you know me also as the Seattle Data Guy. Today we wanted to discuss the concept of what is a serverless database, as well as kind of go into the different use cases that some companies are using it for. In order to kind of help me with that discussion, I brought along my friend Nadine, who works at Rockset as the Senior Developer Advocate, as well as doing all of those things. She also does live coding workshops on Twitch at Rockset Cloud. So if you're looking to kind of get an understanding of both Rockset Cloud as well as some other tools, I think she told me before the stream started that she's doing some stuff with MySQL this week live. You can do that there at Rockset Cloud on Twitch. Really, again, we're going to focus a lot on kind of the concept of serverless databases as well as some other things like cloud native. And hopefully, if you guys have questions on those topics, we can answer them for you. So thanks so much for joining us, Nadine. Let me know, do you want to add anything as far as an intro goes, or is that kind of a good...
Oh, no, I think that's good. Yes, it sounds good.
Awesome, awesome. Well, I guess to kind of just start out the conversation, again, let's focus, I guess, on the first question. So Nadine, what do you kind of feel like, what is a serverless database? And maybe what are some of the examples you've seen that that you are working with, or again, Rockset and the different roles that they play?
Yeah, I think this is a great question. And I think before we get into like serverless databases and serverless in general, we should really talk about cloud native, because I believe serverless really built on top of cloud native architecture. So I'm going to start with cloud native, and then maybe we can talk a little bit about cloud native and then go into serverless. So cloud native can have like many different answers and many different takes. I feel like cloud native is such like a loaded word, and it's a word heavily used across like heavily like marketed things. But in general, when we think of cloud native architecture, one of the main highlights of cloud native architecture should embrace like rapid change. You should be able to have large scale. Largely when you build cloud native architecture, it should also be self-healing, and it should also be easily updated and maintained through CI/CD workflows, and most importantly, be cost efficient. And applications now, have become increasingly complex, where users are much more demanding than they were almost a decade ago, where the application needs to be very responsive. It needs to constantly be innovating on features. You need to have minimal downtime or no downtime. And if there are performance problems or errors, you have the ability to, fix those errors and be able to move fast. And so cloud native is really about kind of this ideal about moving with speed and flexibility. But in a sense, like with cloud native, you might have to still like manage virtual servers or cloud servers, which can lead to a lot of ops overhead. And so this is something to think about. This is kind of where serverless comes in, but I'm happy to hear what your take is on cloud native. Ben.
Yeah, no, I mean, I think you've kind of touched over a lot of the key points. I think it's kind of an interesting point where we're really at that fluctuation point where cloud's been around for a while. People are figuring out, and people, I mean companies of all sizes are kind of figuring out that there are benefits to utilizing the cloud, whether it be to help offload some of their work or take advantage of maybe, I always like to tell, like, for example, with my clients, I always like to tell them, you're taking advantage of technology that large companies are using for a fraction of the cost. So there's a lot of different benefits, as well as, you've got the ability to scale easier. You don't have to necessarily buy out a whole server if you're just trying to test out an idea. So I think there's a lot of little benefits along the way, even again, where you talk about like feature development, you're not having to commit to some huge amount of infrastructure if you're just testing out a feature, right? Yeah. It's much easier to kind of manage. So yeah, no, I think as far as like cloud native goes, I think you've covered a lot of the benefits as well as the things that we're trying to deal with, or like trying to actually like fix along the way, right? Like the whole process of like development has been kind of slow up until, again, cloud native, and I think it's helped reduce a lot of the heavy workloads that a lot of us developers have taken on for a very long time. So I think in that part, I definitely agree. And I think we're finally at a point where people are kind of maturing in cloud, where it's not just, again, a word, like you referenced it, it's like a buzzword. I think we're getting to the point where people are figuring out what works well in cloud, what architecture works well in cloud, like what best practices work well there. So I think overall, from that regard, yeah, I think I agree. I don't know, is there anything else you would add? I guess are there any challenges you feel overall possibly, I guess, that people are facing when they go to cloud?
I think with coming to clouds, you still might have to manage some servers and stuff, and this is where the kind of like the operational overhead and challenges can be with cloud. And I think this is where serverless to me is like kind of like the next generation that's kind of entering, that a lot of developers are adopting for their applications. I think that would be like one obstacle I think with cloud that I see kind of happen.
Yeah. Oh, good.
I'm trying to think if there are other things too with cloud that could be challenging. I think that's the main one I can think of.
Yeah. Oh, sorry.
Go ahead.
I was just gonna say yeah. We're just gonna keep talking over each other. Go ahead.
I was gonna say yeah. Go ahead. I didn't know if you knew of any other challenges that maybe can pop up.
Yeah, I mean, I think that's one of like the interesting challenges with cloud. It's like, as much as it in theory ends up reducing a lot of the workload, I think it again kind of adds this whole new workload where it's like, okay, now you need to manage cloud, which almost because of the fact that it's so easy to set up different components in cloud, it's very easy to suddenly realize you're managing like a Kafka instance, a like Kinesis, like MySQL, Postgre, like, and you're suddenly realizing you're juggling, one developer might be having to juggle 3 times the amount of like technical components they would have had to in the past. So I think that brings up an interesting point in terms of the fact that like a lot of people assume like, oh, it's really easy with the cloud. And it's like, yeah, it's really easy to make a very complex like system or architecture that then becomes very complex to manage, regardless of how easy it is to kind of like spin up those components. So I think that's like an interesting aspect of it as well.
Yeah, and I think this is like where we can kind of get into like serverless now, right? So serverless is not just like embracing like entire cloud services or hardware. It's that your infrastructure stack can reliably run without you having to manually manage and configure servers. So when we think of like serverless, there are a couple of few things that pop to my mind, like DynamoDB screams out, AWS Lambda screams out, and so much more. But instead of having, developers have certain parts of like the application be serverless, but using one or more of these technologies, or they might use one serverless component, I think more and more, maybe now more and more developers are starting to want their whole application to kind of be serverless or more adapt to embracing serverless architecture. And what this means is that like developers don't need to invest in, for example, continuous capacity planning or maybe database tuning to constantly manage cost and performance and so on. So there are a couple of like, when we talk about the benefits of serverless, there are a couple of things that that we can talk about. One is there's no provisioning, right? Developers shouldn't have to concern themselves with the type of hardware they need to provision or to set up a data management system. The other thing that we chatted about is capacity planning. So developers shouldn't have to plan cluster capacity at any point of the application's lifecycle, and this means like they don't have to over provision or under provision their application. Other thing that I can talk about is scaling limits. Developers should have the ability to scale up and down as the demand changes for the application or the product. And the final thing that comes to mind is like, no virtual server maintenance. So they don't have to worry about like security patching, or let's say you have a dependency that got updated. Now you might need to update your application and things like that. All the tasks required should be on support like most of the time or all the time. And so really when we think about the cloud native, which is why I want to talk about first, that serverless to me is like the next generation of where we're headed towards, and having developers adopt more serverless type of architecture in their apps.
Yeah, I think there's definitely kind of been that push, both again with like AWS kind of pushing Lambda and other people pushing similar features, and then again, like you said, some more databases. I think the one interesting thing that I like became more apparent with me is like, you start developing serverless, especially like whether you're doing serverless or even like microservices is, and this is more of like a challenge of serverless, which is like traceability. So I don't know like if there are some things you think about in that area, but like traceability just in terms of the fact that it's like, great, you've now got this so many different components that are connected that sometimes it becomes very difficult to almost trace where a certain API call goes. And that's generally, I think, more on the lines of like serverless computing, where it's like a Lambda function versus like a serverless database. But I'm just curious if you've got general thoughts about traceability, or if that's maybe outside the realm.
I think traceability, like especially when you're dealing with serverless architecture, like it's great for the service that's giving you, that's providing this, to provide that kind of visibility into what might be happening into something that you're doing, right? So if you have a failure, is there a way in the application to detect it? Like, let's say, you're using DynamoDB or whatever, AWS Lambda, and you get a failure. I think it's really up to the company to make that visible. But yeah, traceability is definitely a challenge. But hopefully companies are building to make that more transparent.
Yeah, I definitely think there's plenty of companies that are working to make that more transparent, as well as a lot of tooling. I think that's what's been interesting recently. I've come up with, like, again, because I do everything from writing to consulting, I've come up with a lot more tooling that like people are talking about, where it's like, oh yeah, we're going to do traceability for serverless, which it's one of those things that you don't realize until you start thinking about, oh yeah, if you've got this super complex architecture that's got like who knows how many Lambda calls or something.
Yeah,
it's like, where's it all going?
Yeah, it's real. And I think this comes with time too, as like more developers and companies adapt to a serverless architecture. These types of requests will be constantly talked about in the community, and I think companies will be able to hopefully embrace that and build that transparency.
Yeah. I think that's what we're seeing, and I think just like you said. So yeah, just kind of along this flow, I guess, where do you, like, you've kind of brought up a little bit about serverless databases. Where do you think that they fit in, and what benefits do you think people are trying to take advantage of in that kind of space of serverless?
In terms of like a serverless database?
Yeah, sorry, I didn't finish that statement. I meant serverless databases.
Oh, okay, yes. So I think a couple of things. So what was the first part of the question again? What was?
Yeah, no, I think the first part of that question was kind of focused around like what do you really kind of feel like defines a serverless database? Like, what are the kind of key components, in case someone like maybe watching doesn't know, like they're like, wait, what does serverless database means, right? Like there's got to be a server somewhere storing that data, and then the next part being like, well, why are people trying to use it? Like, what are the like 2 or 3 key benefits that people are trying to take advantage of when they look at a serverless database?
Yeah, so I think when we talk about serverless, goes back to the top where I mentioned kind of the benefits of serverless. So no cluster, no provisioning, no cluster management, and so on and so forth, right? No scaling limits and stuff like that. So when we talk about serverless database, when I think of serverless, we're still thinking about that. But more so, like when we think about that, it makes it like so much easier to get started on and to iterate on. And I can really talk about Rockset. In this case, I know DynamoDB is a great example of a serverless, but Rockset is also a real-time indexing database built for the cloud. And basically with Rockset, it's serverless, where you don't have to do all these things that you might typically have to do with like another database, like, I don't know, like Postgres or something. But basically it's easy to work with the database to be able to get the data that you're trying to analyzing. So in the case of Rockset, in the case you just sign up and then you have you can use the database, you can use Rockset, and then you can either upload your data to Rockset, or you can connect it to DynamoDB, S3, or whatever service, whatever transactional database that you're using, or streaming or data lake or whatever. And then you can just be able to run your queries and then get the results that you want, and then use it in your application. And then in the sense, that's what I think when I think of serverless database. So I can talk about one company that is using Rockset, and one company that comes to mind is Sequoia. So Sequoia, prior, I believe they were working with Elasticsearch. And the thing with Elasticsearch is that you need to manage and maintain the clusters, right? And if you ever worked with Elasticsearch, it's probably a team of 2 or more managing your Elasticsearch cluster. And it's and then like you constantly need to fine tune your cluster. You might need to create and manage your indexes on Elasticsearch and so on and so forth. And it requires a lot of operational burden in that sense. Like you need to have a team to kind of handle this. And with Rockset, there's no cluster to manage. There's no index to manage. There's nothing like that in the sense that you just ingest your data schemalessly in Rockset. Rockset automatically creates 3 different types of indexes for you on each field of your data that you don't have to manage or do anything. And then you can write SQL queries on that schemaless data and then create an API point to the SQL queries that you write and then deploy them. You can get your API and put it in your app so that your app can execute the API. You can get the results back and then do whatever you want with the results. So in that sense of like serverless, that's what I mean. Like when I think of a serverless database, it's really more like hands off in that sense, and that it's easier for the developer to get up and going within a day, right?
Yeah.
If you're using Elasticsearch or something like this, it takes more than a day to get up and going for something like this.
Yeah, no, I think that makes sense. And then if we drill more into that, I'm curious, like what was Sequoia like using first Elasticsearch for, and what they end up using kind of Rockset for, and how do you feel like you kind of fit into like the bigger picture? Because I think one thing I like, especially for anyone watching, I want this to be an opportunity for people to kind of see where different components can fit into like a larger picture. So where did kind of Rockset fit in all of this, and kind of what was Sequoia Capital using it for?
Yeah, so let me think back into Sequoia Capital, because basically they're my computer is like kind of freezing right now. Sorry.
That's okay.
Sequoia Capital, I think, was working on some parts of the data, and I'm trying to remember what exactly they were doing. They were so basically what they had doing is they had an internal system of records. They had a couple of raw data files, and they were using Apache Spark for data enrichment. And basically what they're doing is they're sending their data from S3 and from their internal system of record into Rockset. And so Rockset can run data, or they can write SQL to that data and be able to get the results from the queries that they're writing. And then from there, they're actually using Retool as their visualization type of internal tools to visualize the data that they're writing to Rockset as part of their internal tool. So for Sequoia Capital, I can send the link here in the bottom, but it's more or less building internal analytics or internal tools.
Okay, yeah, sure. If you want to share the link, I don't know if you can post it as a comment. Maybe it'll show up on YouTube.
Oh, I can't post as a comment, but I can send it to you to share if you can.
Yeah, do that.
Okay.
So you guys are going to hear a little ping from Slack, I assume.
Yes, I'll send it to you.
All right. Since you brought that up. If anyone's curious to read more about this specific, I guess, use case, just post it in the chat. Great. Yeah, no, I think that's always kind of interesting to see like how people are trying to use various tooling. Like I know with, like in case of Rockset, like you guys are kind of, I think, in an expansionish phase right now. I think you guys got funding recently, so I imagine you guys are trying to really push both on marketing as well as like trying to figure out like even more use cases. And I think I've felt that even while I've been kind of doing writing with you guys, it's like new use cases are kind of coming up. So it's always interesting to see where everything fits in. I think one thing that I've been seeing recently a lot has been the command Alcon use case. So I was just curious in terms of like what your thought, like what happened, and like what's the recent push there, I guess.
So command, so they're kind of two things that like Rockset is heavily being used for. One is for building internal tools, like with the Sequoia example, and the other one is for more SaaS-like application. This is where your command Alcon comes in. So just to let everyone know, command Alcon is like a cloud-based construction software company that provides kind of like the software backbone for much of the data flowing through construction material logistics today. And they handle almost 80% of the concrete delivery tickets in North America. And their scale is kind of pretty large, where they track like millions of material and hull tickets on a daily basis. And they use this, they have what they call as the Connects platform that surfaces data and analytics to users across the supply chain to keep construction projects kind of running according to plan and make sure nothing fails, because a lot is dependent on this platform. So amongst other things, in terms of like the serverless aspect, which is what this chat is about, they use Rockset to have like minimal operational effort. So what they have is they have DynamoDB as their serverless database. Sorry, I said database. And what happens is that Rockset can fit perfectly into this because they're already using DynamoDB. It's serverless. Rockset is also serverless. And so they send their data to Rockset for them to run SQL and run kind of analytics on it, or like search analytics, if you will, on this. And in the course of one afternoon, they were able to integrate DynamoDB with Rockset. So Rockset has a DynamoDB connector that's managed internally at Rockset. And you can just provide credentials when you create the connection or integration on Rockset. And then data will flow from DynamoDB to Rockset. And then from there, you can run SQL queries on that data on Rockset. And one of the things that they mentioned is that flexibility was by far the most important thing for them, and that their users want to be able to search on any field, anywhere, and they need to give them that ability in the Connects platform. And so this is one of the main reasons why they're using Rockset.
Yeah, I think that's definitely like like an interesting use case. Like overall, that was something that I found, like, as I was kind of just playing around with Rockset personally, like the ability to kind of connect, like you said, like to DynamoDB, and then like from there also connect to something like a stream, like AWS Kinesis or Kafka or an S3 bucket, and then kind of just join all that data together, especially like from perspectives of like when I'm trying to do like ad hoc analysis on my end, like not having to like develop an ETL pipeline or something to like get all this data in one place. It's kind of nice to have that kind of top layer to just do some ad hoc analysis. I think in this case they were doing more of a product that was long-term lasting, but from my perspective, that was something I like ended up liking about the whole kind of system, was being able to kind of go across everything very quickly and having it all work smoothly that way.
Yeah. So when you talk about ETLs, it brings up a good point, because like when we talk about ETLs in general, there is some sort of like, this is different from our serverless talk right now when we talk about ETLs, but generally there's like latency that's imposed when you do ETLs. And so when you're talking about real-time analytics, like speed matters, especially for command Alcon, like everything is running on real time for them. If there's anything that's late, like concrete will probably harden. I have no idea, but like do not need that. So this is where real-time analytics really matters, and time really matters, and query performance really matters. And so if we ever want to talk about real-time analytics and speed, that's probably, we'll save it for another time.
Yes. Yeah, that's I think definitely a whole other conversation. I mean, I think it's definitely somewhere that Rockset, like when I said like Rockset's really trying to move, I think in like a few different areas, in a few different like niches in this place, and one of them being real-time analytics, and not just serverless database. So that's something I've definitely noticed as far as like working with you guys. What else? I think so. That was my key questions. At least I wanted to get answered, and hopefully answer for everyone else. Did you want to add anything else, Nadine, about like kind of your experience with serverless, kind of what you, I don't know, maybe some of the things you're working on right now as far as like with your Twitch stream?
Yeah, I definitely love serverless. It's really easy to work with. And it makes you focus on the app that you're building, have more focus on the app that you're building instead of all the configurations and stuff that can typically take a lot of time of your day and a lot of bandwidth as well. Some of the things I'm working on is really trying to come up with more Twitch streams and coming up with more examples of how to use serverless or real-time analytics in some of your workloads. For example, if you're using MySQL as a transactional database, how can you scale your MySQL to handle real-time analytical loads? So that's something that we're going to explore in our Twitch streams. Recently I built a Next.js app using AWS Lambda, EC2 instances, and then sending the data to Rockset to to analyze what's going on with my EC2 instances. So that was kind of fun, kind of like a sample app of what you can do to analyze logs, for example, of your EC2 instance. But yeah, there's a lot more in the pipeline. The thing is, it's just so much to do, so little time, for sure.
Yeah, I can definitely feel that. As someone who is spending way too much time creating content, yeah, I think at this point people have asked me for like 10 or 20 different videos. It's like Databricks versus like BigQuery, or Databricks versus Snowflake, or so yeah, I can definitely feel the whole, like, there's so much content out there to create. So I feel that.
The Databricks and Snowflake is a very interesting one for sure, and I think Snowflake is playing on a little bit with like some of the ideas of what Databricks is already doing. That's a very interesting one for sure.
Yeah, yeah. I don't know. I think we've got 5 people viewing. I don't know if anyone has any questions for Nadine before we sign off. Feel free to kind of post a comment. And also just thank you so much for joining us. Hopefully you guys got a better understanding of kind of like serverless databases, kind of their role in overall architecture and infrastructure, where you can kind of fit them in. Again, Rockset's one option. You can also look, I'm sure, at plenty of others, but
oh yeah,
obviously Nadine, you're gonna support Rockset, so I'm not gonna sit here and be like, oh, you should, I don't know, go down.
Depends on your use case. Actually, It really depends on your use case. Rockset is really great for real-time analytics, and when you're building applications like logistical applications or SaaS-like applications, or like fraud detection. Let's say you have a gaming app and you need to be able to detect fraud in real time and stuff. This is where Rockset is really powerful because the latency is in milliseconds for a lot of stuff. And you can join disparate data from different sources like streaming, data lakes, data warehouses, whatever, and really run SQL across a lot of collections from different data sources that are coming in and make sense of that data that you don't need to define a schema for or anything like that. So this is where Rockset is really, really powerful. Rockset is not meant to be like a transactional database or anything like that, right? So it's really for an external indexing on top of transactional workloads and so on and so forth.
Yeah, you just got me to my next question. I was say, well, then where does it not work? It fits everywhere. It heals all wounds. No.
And Rockset is not meant to be on-prem either. If you're on-prem, it's really like meant for the cloud. So that's the other part.
That makes sense. All right. Well, I don't see any questions coming, so I think everyone is good. They all perfectly understand serverless databases now, and
I feel like this is so loaded. There's so much more to understand. I barely probably scratched the surface on this.
Oh yeah, I mean, like you could also talk about like the infrastructure itself, right? Like when you're thinking about like what does it look like storage and compute? How does that kind of play a role?
Separation of storage and compute. Yeah, that's a whole other talk about how Rockset does separation of storage and compute. But yeah, that's a big one. A lot of cloud native technologies, many cloud native, I think like Snowflake has a concept of this, does separation of storage and compute. But Rockset does it, decouples compute from storage to improve performance. That means you can scale like storage and compute separately, which is really important. So you don't get charged, you get charged for basically what you do.
Yeah. I think that's definitely one of the big benefits, right? Whether it's BigQuery, Rockset, Snowflake, although Snowflake's tricky with their credits. But yeah, I think that's like, again, like a whole other mini talk. In fact, I recall like when Snowflake was first just like starting like 3 years, well, not first starting, but like when they were really doing their first like big marketing pushes like 3 or 4 years ago. I remember going to a talk, and like that was like the whole conversation of the talk was basically, yeah, this is how we separate storage and compute, and this is how we basically just sit on top of EC2 and S3, and that's all we really do. And we do like micro partitions and like all this very like down in the weeds kind of concept. So that was very interesting.
Yeah, if you ever want to do like a technical architecture of how Rockset does compute and storage, and it's really a deep dive into how that works out in Rockset, always happy to talk about that.
Yeah, no, I think that would be fun. I think especially for some people out there who maybe want to understand maybe more of like under the hood. I think that might be a fun talk. Like, yeah, how does Rockset work? Not just from high level on what it's trying to do, but like, well, how did you guys build it? Like, what's it look like? What what's it based off of, right? Because I think it's based off RocksDB, and like, how did you guys go from there? And so yeah, that's like I think that'd be a very fun conversation to have.
That would be fine, yeah.
Well, I don't see any more or any questions coming through. for this talk. I think we've kind of covered this concept pretty well. Yeah, but if you guys in the future maybe are interested in that talk, may leave a few comments, but also we might do it anyway. So
yeah.
Thank you guys all, and yeah, we'll see you next time.
All right. Bye-bye.
Bye.